All right, so this lesson is about polyhedrons or polyhedra. So these are all examples of polyhedras, just like, where a line, a point on a line separates it into three parts, and then a line can separate a plane into three parts, the line, and then the upper and the lower, and then, so the outer, each of these faces separates things in three parts. It's the surfaces or the faces, the inside, and the outside. So polyhedra, these are different polyhedras. You'll notice some of them look like prisms and cones. And so we look here, we see the number of faces, we see the name. So you can use this chart even on your test. There will be one question on your test regarding this. You're allowed to use that. Because I figure you can use Google in real life, and how often will you have to say that this is a tetrahedron? And so the faces is how we determine it. So there's one face, two faces, three faces, and then there's one back here. So that would be a tetrahedron. Now let's take a look at this one. It's 1, 2, 3, 4 down here, and then 5, 6, 7, 8. And so we go up here, it'd be an octahedron. And so now when you were looking here, we know that there's 6 because there's the front and the back, the top and the bottom, and then the sides. So we go up here, hexahedron. Now let's take a look at this one. So when we looked at this one, we saw that there were 3 sides, and we found that there was 4. This one has, the base has 1, 2, 3, 4, 5 sides. So the base is 5. So then we know there's 5 more. So we know that this is going to be 6-sided. So when it is a cone, we count the sides, and then we add 1 for the base. And so since this is a 5-sided base, it's going to be a 6-faced polyhedron. And so we go up here, hexahedron. Now prisms, on the other hand, like this one, we can count, the 2. So this has 4, so we know there's going to be 4 sides, and then we add 2. So cylinders and cones are going to be slightly different. Now something like this, you're going to have to do a lot more counting. It's going to be much more complicated to count. So we have, on this side, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we know if we can see 10 on this side, if we were to flip it around, we could see 10 more. So it's going to be 20. So this one would be a icosahedron. So when I was looking at the exercises, I saw this exercise, and I decided the best way to handle this would be to do it along with you. So every polyhedron is a cone. So let's take a look. All of these are polyhedrons. This is a cone, this is a cone, but this one's not, this one's not. So we know that number 1 is false. If you want to get out your paper, you can write false. 2, every prism is a polyhedron. All right, so this is a prism. And is it a polyhedron? Yes. This is a prism. Is it a polyhedron? Yes. Are all prisms polyhedrons? The answer is yes. So number 2 would be true. You can write true on your paper. 3, some cones are polyhedra. Well, we've already said that this is a cone and this is cone. Yes, some cones are polyhedra. I have a question for you. Are all cones polyhedras? No. The reason for that is because if this was circular, that is not a polyhedra. The polyhedra is made up of geometric shapes. There is no curve to it. So some cones are polyhedra, but not all cones. So, but your answer to number 3 is correct. It's true. But if it had said all cones, we'd say no, because a polyhedra has to be flat, has to have flat surfaces. A pyramid with a quadrilateral base has 5 faces. Okay, so we've looked at pyramids and we remember, okay, we count the base and then the sides. So if it has a pyramid with a quadrilateral. Quadrilateral is 4. So we'd go 1, 2, 3, 4 for the faces plus the base, which was 5. So number 4 is also true. 5. A prism has only one base. Well, let's take a look. This is considered a prism. This is considered a prism. It has 1, 2 bases. A pyramid has one base, but a prism has 2 bases. So number 5 would be false. Number 6, a circular cone is a polyhedron. Well, we talked about that up here. And if it's circular, it's not a polyhedron. It has to have a flat surface. Number 7, so 6 would be false. Number 7, the smallest number of vertices of a polyhedron is 4. And the answer to that would be yes, because when we have 3 surfaces, we cannot have it be a closed system. So number 7 would be true. Number 8, a cone with a heptagonal base is an octahedron. Okay, so we're talking about a cone. So it's the base plus the sides. Hepta, and I don't need to put it over on the other side. I'll just let you know. Hepta is 7. Hexa is 6. So hepta 7. And then we need, so 7, so there would be 8 sides, and 8-sided is octahedron, just like an octagon. A prism has the same number of faces as vertices. Now, so let's take a look. So this is a prism. And so if we were to do vertices, let's count. 1, 2, 3, 4, 5. So we have 5 around. And then we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And how many does it have? Well, it's a 5-sided plus 2 for the bases, which is 7. So the answer would be false. A prism has the same number of faces as vertices? No. A polyhedron can have no more than 12 faces. Well, the answer is right here. This one has 20 faces. So the answer is false. And then I'm going to have you guys do the rest of these as well as all the way up to 22. I think that you guys can do those ones on your own. Good luck. You guys are doing great. I'm very proud of you guys. Keep up the hard work.